Okay, let's take a look at the first organometallic reagent, which is the organolithium, or it is abbreviated as RLI. R means it must be connected to the organic group, meaning lithium needs to be connected to the organic group so that it is called organolithium. So alkyl lithium or organolithium, RLI, it forms from alkyl halide and lithium metal. So this organolithium is both nucleophile and also basic. So alkyl lithium, it can react readily with copper iodide to give lithium dialkyl copper, or we can also call it as Gilman reagents. And this lithium dialkyl copper reagents, it can react with alkyl halides to give alkanes. And these organolithium reagents, it reacts similarly to Grignard reagents. However, it tends to be more reactive compared to Grignard reagents. Okay, let's take a look at example of how the organolithium is made. So the first one here, if we have alkyl halide and then we react it with 2 lithium metal in pentane, so we can afford butyl lithium as drawn here, and also lithium bromide. So this organolithium reagent, it can be used in the reaction with aldehyde or ketone to give alcohol. Okay, for example, if we look at the organolithium reagent here, because the mechanism is similar with the Grignard reagent, so what happens is that the R group is partially negative while the lithium is partially positive. So the one that serves as nucleophile is the R group. So what happens is that the R group or the C minus will attack the carbon, and then this electron will move to the oxygen, and then it will give us lithium alkoxide, which in turn, when we introduce an acid, it will abstract the proton from the acid and give us an alcohol. So if acidic compound is used, it can be deprotonated and lithiated. Okay, if you look at the example here, this is pyridine. So this pyridine is an acidic compound because it has nitrogen atom here, which is an electron withdrawing atom. And then when it is react with organolithium, so it can give us an organolithium compound, yeah, such as this one. And then reaction of this organolithium with aldehyde and ketones will give us secondary and tertiary alcohol respectively. And this organolithium, since it is a strong base, it can easily deprotonated acidic moieties such as alkyne. Okay, let's say we have alkyne here. Since this RLI is a very strong base, so it can abstract this proton and then replace it with the lithium. And now both of these can now be used as effective nucleophile. So this now can be used as nucleophile to react with a carbonyl compound to give us an alcohol. There are here some example of a reaction which we can use organolithium reagent. So the first one here is when we have a methyl lithium, for example, when we react it with copper iodide in ether, so it can give us lithium dimethyl copper, which is a Gilman reagent. And now this lithium dimethyl copper can be used to form alkane by reacting it with alkyl halide. So in this case it is 1 iododecane, and the reaction is carried out in ether, and it can give us undecane or a long chain alkane as drawn here. Please take a look at the condition of the reaction. As I have mentioned before, this reaction is more reactive compared to the Grignard reagent. Normally, when we do a Grignard reaction, the temperature is around 35 degrees Celsius. But if we use organolithium, the reaction can be done at 0 degrees Celsius, which is very mild compared to the Grignard reaction. So this proves how this reaction is actually more reactive compared to the Grignard reaction. So in the second video, I will explain more on the other organometallic reagents such as organocopper, organocadmium, and organozinc.